Good morning. So we are still in Unit 6. We have 2 more lessons, but the last topic is the substitution method, where we're going to break this into 2 pieces, the indefinite integrals today and the definite integrals in the next lesson. So by using the substitution method, students will integrate compound functions. It's related to that chain rule. When we took chain rule with derivatives, we had to multiply by the derivative of the inside. Well, now with the substitution method, we are going to have to deal with that chain rule and put it back together. So going beyond the power rule and the trig integrals, we will break one larger integral into smaller, simpler integrals to solve, and we will call this U substitution. So just kind of what am I talking about here? If I had the function x squared plus 6 times 2x dx, you could integrate that, but you'd have to distribute the 2x first, and then you could do each term individually. If I squared this, you could FOIL it out and then multiply the 2x, and you could still integrate this. But if I have this to the 24th power or something like that, you wouldn't want to FOIL that out 24 times. That would be ridiculous. So if you have all the pieces, you can do something called U substitution. So the integral of f of u du is equal to f of u plus c, where u equals g of x and du equals g prime of x. And I know it looks a little funny. We usually have a chuckle about this in class. F of u, it's a real thing. We use the actual notation. So example 1, let's jump right in here. Evaluate x squared plus 1 to the 50th power times 2x dx. So u is the inside. Let's go back to highlighting. This is u. Just like with the chain rule. So x squared plus 1 is u. Du is the derivative of that, which is 2x. I want you to follow that up with a dx. So now what we're going to do is rewrite that original problem in terms of u. So this becomes u to the 50th du. Now, go back and look at this. Here's your u piece. Let's make that purple again. U to the 50th, everything is u. That's usually the easier piece. The trickier piece is making sure that du matches. You need a 2x dx. You have to have that in the problem for this to work. And here it is, 2x dx. So I'm replacing 2x dx with du. Now that I have everything in terms of u, we can actually integrate. So the antiderivative of u to the 50th is u to the 51st divided by 51 plus c. And then we're going to replace u back with the original, the x squared plus 1.
It doesn't look anything like the real answer.
There you go. It might be helpful to write that fraction 151st in the front, depending on where you're looking up your answers or what you're doing next. Both of those are acceptable versions. So this is U substitution. I kind of like it. Guidelines for U substitution. Look for some composition of U and du. Try to evaluate in terms of u. If steps 1 and 2 are successful, replace u with g of x to express your answer in terms of x. So example 2, let's just focus on one thing at a time here. What's your u? Your u is what's inside, so it's x plus 9. Your du is the derivative of that, which is 1 dx. So you need to rewrite this in terms of u. So this would be the sine of u du. And everything matches. Here's my du, 1 dx. That's all good. And x plus 9 becomes the u, so that's all good. So then the antiderivative of sine is negative cosine of u plus c. Remember, the derivative of cosine is negative sine, so if I start out with a positive sign, the antiderivative is negative cosine. Now, u is just a stepping stone to get us to the answer. You'll never have u in your final answer. You have to replace u with the x plus 9 that we had originally. And there is your integral. Good job. Example 3, same idea. What's your u? U is x minus 8. What's the derivative of that? Well, it's 1 dx. So we rewrite this as u to the 23rd du. Here's my x minus 8. That becomes the u. Here is my du, which is the dx. All of that gets replaced. So now that everything is in terms of u, this becomes u to the 24th over 24 plus c. Now, you did the calculus, that's taken care of, but you don't leave your answer in terms of u. You have to replace it with x minus 8. So this is x minus 8 to the 24th over 24 plus c. Remember, those indefinite integrals get the plus c on the end. Don't forget those. Example 4. Now, they can't all stay that easy, right? Your u is what's inside. There weren't parentheses there, but remember that 5x is inside of the cosine. So u is 5x. The derivative of that is 5 dx. We have a bit of an issue in that when I look at the u piece, 5x, well, that matches up. Everything's okay there. This is going to be cosine of u. But the problem is the other piece, dx. I have a dx, but I need a 5 dx. Now, this is the way that I've kind of taught this. This works for me. If you look up videos on Khan Academy or other videos on YouTube, they might talk about dividing and do it a little bit differently, but you get the same result. So when I look at this, I see, all right, I need a 5x. I only have a dx. So I need to put something into the problem. I'm going to put in a 5. Mrs. Charnley, you can't just put a 5 in the problem. That doesn't work. No, but I can balance it out with a 1/5. So 5 times 1/5 has a net change of 1. That's totally fine. So this 1/5 is going to sit in the front. This 5 dx is what I'm looking for. All of that becomes du. So we have to take care of that 1/5 in the front. Now, we still have to integrate. The antiderivative of cosine of u is positive sine of u plus c. And don't forget about the 1/5 in the front. And in place of u goes 5x. This is what it looks like. Awesome. So that other method that I was saying some people might use is they take the du, and maybe this makes more sense to you. Great if it does. They say du over 5 is dx. So they'll rewrite this as cosine of u. And then up here where the dx is, they replace that with du over 5. And then pull the 1/5 to the front. And then integrate from there. I'm totally fine with that, except when you get variables involved. And if you get variables involved, it's a little tricky because you're not allowed to add x's into the problem, only constants. All right, there's example 4. Example 5. Same idea. U is what's in the parentheses, so it's 1/3 x minus 8. The derivative of 1/3 x minus 8 is 1/3 dx. I don't have a 1/3 in the problem. I'm looking ahead here. I need 1/3 dx, but I only have a dx. So again, I'm going to put that piece in. So I need a 1/3, but if I put a 1/3 inside, I need a 3 outside. So when I rewrite this, it becomes 3 on the outside, the integral of du over u to the 5th. Now, I don't think we've actually mentioned this in our antiderivative unit, and we probably should have. You cannot integrate u to the 5th when it's sitting in the denominator. You must move that to the numerator. So this is u to the negative 5 du. There is no quotient rule for integrals. The antiderivative of u to the negative 5 is u to the negative 4, divide by negative 4 plus c, and we put the 3 in the front. So this becomes negative 3/4. What's my u? Oh, I should zoom out. 1/3 8 minus x to the negative 4th plus c. Now, you could make that positive, but I was reading in one of the message boards the other day about simplifying on the AP exam. It's all risk and no reward. So I know that when you're in Algebra 2 and pre-calculus, we say, oh no, negative exponents are bad. When you get to calculus, we have more important things. So we don't care about negative exponents so much. In fact, they're helpful sometimes. So either one of these would be acceptable answers. But if you simplify, just make sure you do it correctly. Good. Now, example 6, and I think this is our last one. U and du, this one's a little bit trickier in that I don't have parentheses out there right away. But if you recall, back when we were doing chain rule, my suggestion to you was write this as sine of x quantity squared, cosine of x. And then it's easier to see what's inside. So when I look at this, what's inside is the sine of x. The derivative of sine is cosine of x dx. And if I look, this one matches up nicely. We're ready to go. So here is my u, sine of x. And my du is cosine of x dx. So when we write this, it's u squared du. And I didn't have to balance anything out. So the antiderivative of u squared would be 1/3 u cubed plus c. And in place of the u goes sine of x cubed plus c. Maybe something like that. There you go. So u substitution, not too bad. Tomorrow we'll tackle the ones that have numbers on the limits, those definite integrals, but u substitution, I kind of like it. And I've heard from some students that they like integrals a little bit better. I agree. Once you get to derivatives, they're all kind of strange, but we've been working with them for a couple months now. So once we get to integrals, you're like, oh, they're just derivatives backwards. They're not so bad. Make sure that you're working on memorizing anything on that golden ticket. In this remote setting that we have where things are kind of open notes, we're not getting that memorization like we would in a traditional year. So make sure that you're working on memorizing those. But if you have questions, make sure you email me, send me pictures of your work, stop by my Zoom, and we'll help you out.